So if we look back on page 21 about the empirical rule and bell curves or normal curves, we know that these have very specific percentiles or percentages that fall in between certain ranges. Now, I didn't, do these really work well for symmetric distributions? This distribution of grades certainly isn't symmetric. So I'm going to show you how it doesn't. You got to have a symmetric distribution to really do a normal a curving grading on a curve. Okay, there's ways to take values and maybe make them somewhat normally distributed. It's math magic. It's sometimes it doesn't work. Often it doesn't work. But here's one way to do it. If I know that 68% fall in the middle, typically that's the C range. And then if we go up a standard deviations, typically that's the B range. And then it'll be an A range, everybody above that. And then so C, D, and everybody below that would be an F. So what I did with these values is I said, okay, so if I've got the middle 68%, I know there's 16% below that and 16% above it because, 100 minus 68, 32. And since it's symmetric, half is below, half is above. So I found the 16th percentile of these scores, these 17 scores, and that's the third number, which is a 48, and the 84th percentile, because 100 minus 16, right, is the 84th percentile, and that gives it the 17th number would be the top end of that middle, and I think that was a 96. Looking at my work here, yep. So that means anyone between 48 and 96, that would put 68% of this group of 17 students in the middle with the C. And then to get the next bit, well, I know that, where did I do the 95? Did I do that down here? Oh yeah, here. So then I said, here's the middle 95%. And so I found that leaves 2.5% below, 2.5% above. So to find those percentiles, that the first number is at the 2.5 percentile, and the 17th number, it cuts the top of it. And so that means nobody. So what that means, what does that mean? I wrote that down here. So that means this would be the breakdown of grades. That meant 0 people fail, 0 people get A's, 13 people get C's, and 2 people get D's, 2 people get B's. So boy, it doesn't seem fair to me to those what were there how many people that got in the 90s from this problem. Let's see, number 20, right? Yeah, there were 1, 2, 3, 4, 5 people that got really earned A's, and they only ended up with B's, and some of them might have ended up with what was the breakdown for a B? Yeah, you would have had to get a 96 to get a B. Hardly fair. Okay, now the people on the lower end of the scale, yeah, they made out pretty well. So then I tried, well, what if I did something a little different? What if I checked for outliers and check on that, because I know this is some kind of weird skewed distribution. So I found the lower quartile, the upper quartile, find the lower fence. There's no outliers based on that 1.5 IQR test, since it's skewed distribution. So that didn't help. Truthfully, what I'd probably do is I'd throw out, I'd say everybody who had a 90 or above, give those people A's, and then I'd play around with the rest of the scores. And, I'd probably say anybody less than a 50 failed. And then I'd do something with the remaining scores and, add some points. I wouldn't try to curve it at all. Yeah, so I guess that's it. It's no easy. I mean, grading's a hard thing. I remember seeing at UVM when I was a forestry major there was an organic chemistry mid-year exam or mid-semester exam, and the professor had posted the grade distribution on his door, and there were people in, with failing with a 70, because he only let this have people. He had to trim people because they wanted it. It was a merit-based grading system, and they only wanted to have so many people continue on to med school or whatever. So it was pretty sad. That's where I my first exposure is how grading on a curve isn't necessarily fair. I'll generally what I'll do is, like I said, I'll make those non-ease A's, and then I'll do some kind of sliding scale, set up some linear function, some mx plus p function. I'll say, here's the average, here's what I want it to be, here's the minimum, here's what I want it to be, and create a line and plug in the values and do it. Doesn't make it normal, but sometimes that's fair, especially when you're putting people under pressure to perform. All right. I guess this is long enough video.